Without gravity, we couldn't jump on this trampoline. Woohoo! Yeah.
Welcome to Mathematics Theater with our host tonight, Matt Menger.
Hello again. Tonight we will be talking about Isaac Newton. Born on December 25th, 1642, in the small town of Woolsthorpe, 100 miles north of London.
One of Newton's major contributions to the field of science was an equation to tell us how fast an object is going at any given time in its descent. That equation is the velocity at any given time equals the initial velocity plus the acceleration of gravity times time.
Albert Einstein, born in 1879, was one of the greatest scientists of all time. He was best known for his theory of relativity. He also made many other contributions to science.
Einstein said, quote, "Bodies which are moving under the sole influence of a gravitational field receive an acceleration which does not in the least depend either on the material or on the physical state of the body. In other words, mass, shape, and size don't affect the rate at which it falls."
Newton said that force equals mass times acceleration. Einstein said that force equals gravitational mass times the strength of the gravitational field. We can derive this equation that mass times acceleration equals the gravitational mass times the strength of the gravitational field. Since mass is constant, we can cancel the mass and the gravitational mass out of both sides of the equation, and we're left with one final equation that force equals strength of the gravitational field, which Galileo said.
Galileo was an Italian astronomer and physicist who was born in 1564. And he was the founder of modern experimental science.
Galileo conducted experiments where he would drop different objects of different masses, and he noticed that they always hit at the same time regardless of their mass. Let's make an example of Galileo's statement that different objects of different masses fall at the exact same rate. We'll be dropping 2 water balloons from a tower, like so, and observe. 1! Perfect. They both hit at the exact same time. Now let's test Newton's equation by dropping a watermelon off that exact same tower. 2, 1, go.
Oh.
I got it.
Dude, that was
I got it.
I like this.
Okay, you need to shut up, Allison. Okay, now that we've dropped the watermelon, let's see how fast it was going when it hits the ground. Let's use Newton's equation. Velocity at any time equals the initial velocity plus the acceleration of gravity times time. It took 2.67 seconds for the watermelon to hit the ground. So let's plug these numbers in. The velocity at 2.67 seconds was the initial velocity plus acceleration of gravity, which is 32.174 feet per second squared, times the time of 2.67 seconds. Okay, so to do the math, the velocity at 2.67 seconds is, initial velocity doesn't matter, so we can skip it because the initial velocity was 0. Okay, so our final number is 85.90458 feet per second. All right. Okay, that's good. You can shut it off now. Andrew, you suck. Turn the camera off. Dang it. Go look at Allison.
This is hilarious.
Look at Allison.
Stop.
Don't look at me. Here.
Let's review.
What we're about to tell you is very important. You need to remember that the mass of an object does not in any way affect the rate at which it falls towards the ground. Our next very, very important fact is that Newton's law to find the speed at which any object is falling at any given time is as follows. The velocity at the time equals the original velocity plus the acceleration of gravity times the original time. Or, in other words, get out a piece of paper now. V, parentheses t, equals V subscript O plus A subscript G times T.
And that's all.
Stop. Thank you for joining us.
Albert Einstein, born in 1879, was one of the greatest scientists of all time. Albert Einstein, born in 1879, was one of the great. I can't believe it. I'm like holding the microphone over here. He was one of the greatest scientists of all time. Stop. Okay. Albert Einstein, born in 1879, was one of the greatest scientists of all time. He is best known for his theory of relativity. He also made many other contributions to science. Why am I doing this?
I just stopped it.
Oh, there you go. That was good.
Matt, what's your phone number?
What's my what?
Phone number.
550-9264.
I'm going to call my house and leave the number with my dad.
Okay, fine. As long as you can.
550-9264?
Yeah.
Alright, where's the phone?
Inside on the kitchen counter.
All right. Now let's illustrate Newton's law. Let's take Matt here, for instance. Matt weighs approximately 500 kilograms. And I'll be pushing him against his bed at approximately... Oh, God, I don't know.
Cut.
30, no.
Okay.
30 joules per gram, okay? Let's find, Let, 2, 3, go. Go! Go!
Gravity is cool. Gravity is cool. Gravity is cool. Gravity is cool.
Y'all are gonna get hit. It'll fall down really far. This watermelon's got some momentum. Oh, what the heck? Record the driver's ed car. Record the driver's ed car.
Hit clock.
You got it? Okay, ready?
Go.
Wait, let me get that out of the way first.
Oh, shit, incoming. 2, wait.
Wait, it's going far.
3, 2, 1.
Oh, shoot, that sucked. It's good.
Yeah, I can't find it.
Oh, well.
Someone else named it.
That was cool.
Andrew.
Cool. Yeah. Okay, we gotta go now.
Oh, man.